Yes.
So let's talk about HDF5. It's one of those things, if you have worked with it in the past, you probably have an opinion about it. It's sort of the, I don't know, from what I've seen, arguments, there are big disadvantages and advantages about HDF5, and I will try to cover most of it. It's just to start off, what is HDF5? In some people say it's a file format for storing HDF5 data, and we'll get to what that means in a moment here. It is a data model because it allows you to logically organize and access this HDF5. Everything in the data model or in the file is technically a data object, and this data object, to make it nice and flexible, can be literally anything from a text file to some audio files to some animations, whatever it happens to be. If you can describe it, organize it, and all that sort of stuff, you can save this thing in HDF5 in any way, shape, or form that you see fit for your applications. And if you ask the HDF5 group that develops this, it's like, who's actually using that? This is literally used from anybody, from folks, say, from the film industry to folks that actually sort of supervise nuclear tests and all that sort of stuff. Everything in between. HDF5 really allows you to do things. As I said, data sets can be organized and contain raw data values or any type of values that you make out. It consists of the data as well as the metadata. It has predefined data types. You can define data spaces, so the whole thing can be any dimensions as you want. Every data object can have all sorts of properties and attributes. That's kind of, if you come from a GIS world, then you know what to do with attributes. So that kind of covers in a nutshell, and we will go through those in more detail there. The data model at the other end, HDF5 is also a software. It has a number of APIs and libraries so that you can talk to the data and the files. So you can access things programmatically. And there are a number of tools out there, and I will particularly have a look at the second one that is over here. The HDF view is actually a tool that lets you open and interactively look at HDF5 files. The H5 dump is kind of, as it suggests, is a command line tool that lets you, look at data just from a command line. Any terminal would do, and you have a number of tools. The H5 dump is probably one of the most often used HDF5 specifically for any of the data that we have over here, since there is geographic information in there as well. If you're familiar with the GDAL tools, the GDAL info will pick up whatever it can decipher from an HDF5 file as well. So that is what HDF5 is in a nutshell over here. The data format, as I said, is flexible, and it is a self-describing format. There is not like GeoTIFF where you have a number of predefined tags that you need to fill in. Some are required, some are optional. The entire data format is self-describing. So if you can store it in it, you can actually take a tool, HDF view, for example, to actually look at the data. There is nothing that you can't, as long as you can store it properly in there, it's perfectly fine. As I mentioned before, it supports standard and what they call compound data formats. So you can literally look at anything that you can figure out as that is a string, a text, an array, whatever it happens to be. You can use those standard data formats, or the format allows you to come up with your own compound format. So this is a user-defined thing. If you just want to have your own way of, say, storing the complex data, if you want to store this thing as an amplitude and a phase value, you can. I mean, if you want to store this thing in, any other structure that helps you to deal with the data, you can absolutely do that. You can have multi-dimensional data structures, and there's really no limit to how many dimensions you can have, as long as you can describe it, organize it, file it. It can be done. This is more sort of the under the hood part. Is like the data can be either stored in one consecutive block, or you can if that makes more sense, you can chunk it up in different pieces. You can compress the data. There are an increasing number of compression algorithms that the libraries actually support there. So there's no reason to say it's like, okay, this could be your equivalent of a zip file if you really want it. As I mentioned before, there are attributes associated with the data objects. This is kind of your bread and butter GIS kind of a thing. Whatever object you have over there, you can assign any number of attributes that describe what that is. There are some things, obviously, with the data objects that you need to know, kind of what data type it is. That sort of thing is required. Any other attributes, such as the metadata, where you say it's like, okay, this parameter might help to have a unit defined for this, is the kind of things that you would put in attributes there. So the flexibility, as I mentioned before, is like people are, it is very nice to have the flexibility, but that flexibility comes at a price. There is really no standard for the remote sensing products that I know of that actually uses HDF5. It is that way since there is really no one standard. The GIS environment support is somewhat limited. I mean, there are some efforts to try to come up with more standard product specifications, and that's probably at the level that you can find a standard, but anything else is kind of going to be a little bit more difficult. And just to get ideas like why, especially with SAR data, things are so complicated. You might remember that I think when Eric talked yesterday about NISAR data, he said the NISAR data is stored in standard framing. So it's like, there's a standard size frame. The coverage is always going to be the same. If you compare that to Sentinel-1, which, the smallest processing unit is a burst, these two satellites are really not anywhere close to each other. The way they acquire and process data is done in a very different way. So it's this thing about if you have a processor that would handle Sentinel-1 data, I should say, it is not going to do you any good for NISAR data. Even if you adjust a few things here and there, that would just not do in terms of processing the data. And with that, it's the kind of a thing you have to consider. Then it's like, okay, what are the parameters that I would need to describe the processing and whatever happens to the data for Sentinel versus NISAR. This is not going to be anywhere similar. So coming up with a standard way of doing those, especially when it gets to metadata and parameters, things get complicated. And Joshua was talking about the processing, especially the synthetic aperture radar part. When you get, it is not as simple to get from the data to an image. I mean, there is a lot of processing involved, and things get kind of tricky, depends on how you acquire the data and all that sort of stuff. So all this together will give you a sense, is like, at least for the SAR data, that if you want to save at least the lower level products in an HDF5 in a common way, you will have some issues there. Having said that, I mean, there is obviously the moment you go to the higher level products, say the level 2 is already geocoded. So kind of the SAR geometry and the processing parameters, they are of interest, but they are really not needed to store the information in the file or get things into a GIS. Everything at the level 2 and level 3 that Eric was talking about, the soil moisture products, they are output of some more advanced processing, and they come geocoded in a map projection as well. So it's like there is a possibility to kind of, at least from that end, get to some standard, but chances are the application and what other supplemental information, and we talked about that in some of the tutorials yesterday, the supplemental information that you need for your specific application, chances are would not fit into a standard format either. It's like, if you look at GeoTIFF, as nice as a format as it is, everybody uses that, but apart from map information, map projection information, and some of those, there is really no standard way of getting metadata in there that you would need, or a certain structure not really required. That's what you get with HDF5. As I said, some people find it advantageous. Some people say it's like, is there any alternative way that is easier to deal with? As I mentioned, the software library support. Here are a little bit more details, just to give you an idea, what the lay of the land is. You have official support of APIs in a number of programming languages. There are third-party bindings that get you into the higher level programming languages. Python is just one of them. One of the things of note probably is that the NetCDF4 library is based on HDF5. NetCDF is a format that is primarily used by atmospheric science users. So it's geared towards model data, so higher level products, and they are stored in NetCDF, but the entire library is based on HDF5. So the entire sort of programmatic support is sort of baked in there. I mentioned already the browsers. There's just more than one. I will show you the HDF view as a browser, but there are other browsers and editors out there. If you find that the HDF view has its limitations for your particular purpose, definitely there's more stuff out there to test and try. This is kind of a typical view of a file opened in HDF view. You see on the left side there is the file name first, and then there is what you see. This is the typical group structure over there. As I said, you can whatever makes sense for your application. There's like, you have in the science group over there. Over here, there's LSAR, which means that this is the L-band data. In the same way, you could, if that is ever something that you need to know, it's like you could store the S-band SAR data on the same level. The next GCOF is literally the product type. So this is ground geocoded covariance matrices. The next thing that you have there is a grid, and then it goes down. What you see over here is in the frequency A, and that's kind of what Eric was talking about. the range bandwidth cases that are in the acquisitions. I will not go into the details over here, but what you see here is sort of the attributes and everything related to the HHHH data set that is actually stored in it. As you see over here on the right side, these are all the attributes over there. It's like you get a name. Okay, how do I need to talk to the, I mean, if I want to programmatically extract the entire thing, it has a type, so it gives you an idea. What is it? Is it a, a floating point? Is it a string? Those kind of things. And then you have the values on the right side over there. It's like, not in this case, not everything is populated, but it gives you an idea what the functionality and the ability of the HDF5 is. So once you open the file, you can actually this is a fully interactive thing. I mean, if you look for a particular value or that sort of stuff, this is an easy interface where you basically just search and kind of look into the detail of the entire structure of the image there. There is limited visualization in this thing, but at least you have an idea, what the dimensions are and all that sort of stuff. You can all work that out with the HDFU. So this is probably your first best bet. Looking at the files, what am I looking at? What are the bands, or what is the data in there? What kind of metadata do I have? Is all the things that I need for my analysis in the data, or am I missing something? So this is kind of the first bet on that. What I have, and that's something we'll pick up a little bit with the subsetting. The one thing that I did to sort of programmatically look into the entire thing. I should probably preface this part here is as Eric mentioned, just like at the moment we have the first NISAR sample data, and this is what I used for that. But there is more complete, more populated sample data to come. So it's like this is the main reason why I'm talking about this entire thing here as sort of screenshots, because there's really not enough data out there for you to do something particularly useful yet. I mean, things are evolving. Things are getting more complete, in a little while. So with probably whenever the next early adopter workshop is, by that time we probably have things a lot more sorted out. But this is kind of partially implemented, prototyped, and as you will see when I will be talking about the subsetting part, we will have at least the conceptual idea how we want to go about things. So what I have done over here is taking the HDF5 data and basically saved in a spreadsheet what kind of parameter, sort of the middle column over here is the parameter, as you have seen here on the left side. This is literally the same thing written in. It's like, okay, what is the entire path to the parameter? What data type is it? Is it an array? Is it, if you're familiar with Python, bytes is a form of a string. Those kind of things. This is a floating point number. And on the left side, it's kind of, okay, am I looking at a actual value? Am I looking at an attribute? This helps me to extract the data and the metadata from the file. So I have an Excel spreadsheet that sort of predefines what I'm looking at. As I said, the flexibility is fine. I'm predefining the structure as I will find it in the HDF5 in a spreadsheet, because that is easy to edit and all that sort of stuff. So if anything changes, I just need to update my spreadsheet and not necessarily the tool that I'm using for extracting. So I'm extracting then the data that saves the data with its type that I mentioned, and the data type in a JSON file. JSON is probably just the easiest to look at and to parse. And another way is to extract the metadata that saves the metadata with the attributes and the values. And I have, this is an example on the left side. It's the data. It's all a little small here, but it's like I want to get, the entire thing at least as a screen capture over there. The thing on the right side is the metadata, where you basically get the entire information. It's like, okay, where do I need to look to extract all the information? As you see over here, the shape gives you the dimensions of the data. So it's like 6,000 times 4,500. That's the size of the HHHH. So that's kind of the thing I need. I can use that information to kind of extract things out of the HDF5 file with that information in there. So that's, I think, from the HDF5 part of things. As much as I want to talk about that, we'll pick up this discussion, I guess, when we talk about subsetting. There are a few more things that I did, and I will show you the processing strategy as we currently have to go about subsetting. And I think with that, I give it back to Alex.
Great. So actually, we do have one question in chat from Andrew Johnston. So the NISAR sample products, while H5 HDF5 files are labeled as the following NetCDF 4 CF 1.8 metadata conventions, what interoperability should users expect when using NetCDF compatible tools with NISAR data files?
I know currently the CF convention is something that the NetCDF community defined. CF stands for climate and forecast. So they identified a number of files and parameters, particularly about map projection and all that sort of stuff. As far as I know, the NISAR, the product specification spells out that all these standard CF conventions are filled out. I'm not sure that currently they fully are. So I expect a more basic support, looking at these conventions that at least spell out what the map projection and all that sort of stuff is. So yeah, there's more to come, definitely. So expect, and I don't know to what support that is, NetCDF. GIS support is also limited to some extent. We'll talk about that in the subsetting. There's this thing about currently you have to kind of deal with every subset that is in the data sort of separately and not as the entire group. What you rather would have if you have various covariance matrix bands in there. If you subset something or if you extract numbers, you would probably like to have it for all the bands and not just for one selection at a time. So there are some things that were probably doable, but a little clunky at best at the moment. But we will get there.